Lesson number 85 is about stem and leaf plots and histograms. Now here we have scores from a recent test, and this was not from your class. There's obviously not enough people in this class, but these scores from the recent test: 95, 90, 97, 100, 85, 75, 82, and 64. You can see we've got lots of high grades, a couple middle grades, and then a low grade in here. So the scores from the recent test, we could show this data in a couple different ways. One way to show this would be using a stem and leaf plot. Now a stem and leaf plot is arranged in two columns. We've got our stem on the left and the leaf on the right. If we think about it like a tree, the leaf is held on by the stem. So it's the same way in a stem and a leaf plot as we work through this. So the stem is going to be our first number, or our first two numbers, and our leaf is going to be our ones digit. So if we look at that, our stem, we've got numbers in the 60s, 70s, 80s, 90s, and hundreds. And then our leaf is going to be, well, for the 6, there's a 4, so that means 64. For the 7, there's a 75. And for 80, well, for 80, there's an 82 and an 85. So we're going to put a 2, and then we're going to put a 5. And you've got a choice here. If you'd like to put a comma, you may. You don't have to, though. If you don't put a comma, make sure you leave a big space here, because the leaf must only be one digit. We're not going to put a comma this time. For the 90, you can see we have a 90. We've got a 95 and a 97. For the 10, or the 100, all we have is 100, so we need to put a 0 here. Now this is an example of a stem and a leaf plot. Now a stem and a leaf plot is a nice way to visually display data. It's not the only way that we could show this, though. We could also show this as a histogram. And if we wanted to show this as a histogram is just a type of bar graph. So our histogram, if it's a type of bar graph, would look something like this, where we've got our x-axis and we've got our y-axis, and it shows the number of times that things happen. So maybe we had scores from, let's say, 60 to 69. We'll just keep it in the 60s. Then we have scores from 70 to 79. Then we have scores from 80 to 89. Then we have scores from 90 to 99. And I'm running out of room, so I'm going to make my graph a little bit bigger. And then we have scores from 100. Well, there's only 100 here. So this will have to be the way that we set up our histogram. Now, we want to say the number of times each thing happens. And we can see that this is going to have a maximum of 3, because we've already used it from our stem and our leaf plot. So we're going to have a 1, a 2, and a 3. And then we can make our bars. So for 60 to 69, we only have one occurrence. And that happens one time. So it goes across right at the 1. For 70 to 79, we only have one time. So that's also a 1. These bars are level. Then for 80 to 89, we've got 2 times. So that's happening 2 times. 90 to 99, we've got 3 times. And then our lonely score out there of 100 only happens 1 time. Now a histogram, and we're going to call this one actually 100 plus, in case somebody did have extra credit. Let's call it 100, and we'll make the intervals the same. Instead of just calling it 100, please make sure you erase this as well and get it correct in your notes. We're going to call it 100 to 109. So we have the same intervals throughout. So we've got our histogram. All we need is labels. So this is the number of occurrences. And this is our interval, or our score. Our score interval. So the number of occurrences and the score interval for our histogram. Notice all a histogram is a stem and leaf plot moved onto its side. So if we take this stem and leaf plot and we rotate it like this, you can see we have 1, 1, 2, 3, and 1. And if we moved it over and put it right on top, Well, they're not exactly the same spacing, but you can see that a stem and leaf plot on its side is the same exact thing as a histogram. Now, let's look at a few examples. This example says, find the A range, B median, and C mode of the data shown in the stem and leaf plot. Now, stem and leaf plots are really nice for working with data, because in this one, our range, the biggest minus the smallest, well, the biggest must be 83, and the smallest must be 41. So 83 minus 41, that must be equal to 42. And we've got our answer. Now for B, the median. This stem and leaf plot is arranged in numerical order. Some of them may not be, so you have to rearrange the numbers. But for our median, we can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers. So we've got 13 numbers. That's an odd number of numbers. So we must have 6 on one side, 6 on the other side, and our 7th number, that must be right in the middle. So let's find our 7th number. 1, 2, 3, 4, 5, 6, 7. Then we've got 1, 2, 3, 4, 5, 6 on the left, or the small side. 1, 2, 3, 4, 5, 6 on the big side. So our median, our middle number, must be 67. And we've got our answer. For problem C, our mode, well, the mode is the number that happens the most frequently. And we can see there's only one mode here. 81, 81. It happens twice. So our mode must be 81. Finding these types of statistics from a stem and leaf plot can be quite easy comparing to just having them written out in a list. Now let's look at a problem with a histogram. A histogram is just a graph showing frequency distribution. So here we have final scores, and we can see the number of students that had these scores. We can see we have intervals between 90 to 100, 80 to 90, 70 to 80, 60 to 70. This one looks slightly different with our score intervals than we had in our first example, but it's still a histogram because it shows a graph showing frequency distribution. Now, a question that I may ask is, how many students scored between 70 and 80? So 70 to 80. How many scored between 70 and 80? Well, here's our bar between 70 and 80, so this goes up halfway between the 8 and the 10, so it must be a 9. And we can use this histogram to figure out more questions. We could also ask how many scored from 80 to 100. Well, 80 to 100 is these two bars put together. So our green bar, that looks like it has between 12 and 14, because this is by 2's, so this must be 13. And 90 to 100 must be between 4 and 6, that's 5. So 13 plus 5 is equal to 18. And we can get lots of different types of statistics or important pieces of information by reading these histograms accurately. Our lesson practice will be on page 355. Make sure you've got your notes complete, and I'll see you during our next class.